In this video, we're going to graph linear equations by utilizing slope and y-intercept. So before we start actually graphing with slope-intercept form, what we're going to do here is we're going to look for a couple of key patterns that might help us with our graphing. So here I have three different equations graphed. The first one is y equals 3x minus 7. The second one is y equals 3 minus 2x. And the third one is 1/2 x plus 1 is equal to y. So, first thing we're going to do is we're going to identify the y-intercepts and the slopes of these graphs. So when I look at these particular graphs, when I look for y-intercept, I'm looking for the point where I cross the y-axis. So here on the first graph, I find that my y-intercept point occurs at 0, -1. On this next graph, I find that this occurs at 0, 3. And on my next graph, I note that this occurs at 0, 1. Now, for slope, there are a couple of different ways that I can calculate slope. I can either do so by looking for the rise over run on the graph, or I can use the y2 minus y1 over x2 minus x1. Either strategy will work. Because I have the graphs physically in front of me, I'm going to utilize the rise over run trick with the slope. So here I'm going to pick 2 points. Here is my first point, here is my second point, and I'm going to move from point 1 to point 2, and then document my rise over my run. So as I go from point 1 to point 2, I notice that vertically, I go up 3. So my slope here, the vertical change is a positive 3, over my vertical change is 1 in the positive direction, so plus 1. So my slope, if I simplify this, is just 3, or 3 over 1. And then if I look at this second graph here, I notice I have to pick 2 points, so there I pick my points. Then to go from point 1 to point 2 here, I notice that my vertical change is a -2, so my slope is -2, over, I then move a positive 1 in the horizontal direction, so positive 1. If I simplify that, my slope is -2 over 1, or simply -2. And then over here, I'm going to find my slope. I'm going to pick point 1 and point 2. To vertically move to the next point, I have to go up 1. So my rise is a plus 1. And then I need to run plus 2. So this simplifies to be 1/2. So now that we've identified this key information, what we're going to do is we're actually going to start relating it to the equation. So what I'd like you to do is take a look up here at each of these equations. So we see y equals 3x minus 1, y equals 3 minus 2x, and y equals 1/2 x plus 1. And essentially what we're going to do is we're going to look at patterns amongst these and see if we can find out how they relate to the y-intercept and the slope. So the first thing I'm going to do is I'm going to look at the y-intercept points. And what I notice here is that my y-intercept point has a y value of -1 in this first problem. So I'm going to look up at this equation up here and see what I notice. I notice that my y-intercept has a 3 in the second one. So I'm going to look at the second one here. And what I notice in the third one is that my y-intercept, my y value is equal to 1. So I'm going to look at that here. And what I notice is if I focus on the -1, the 3, and the 1, I notice that I have a -1, a 3, and a 1 in each of these equations. So I can see that there is that y-intercept somewhere in this equation if it's written in y equals form. So what I'm noticing is that the number without the x, so this is called the constant value. So if we have this written in y equals form, the number without the x or the constant value is our y-intercept point, which is kind of cool. If we have it written in y equals form, which is function form, we can actually just look at that equation and immediately identify our y-intercept. It's a nice, easy little trick. Now, the second thing we're going to do is we're going to look at these slope values. So our slope here, we have 3, -2, and 1/2. And if I look up here into this equation, I'm going to look for a 3, look for a -2, and look for a 1/2. And what I notice here is that this slope value is also found in this equation if it's written in y=, form. So I notice that the slope is the coefficient of x. So that number in front of x, the coefficient of x, is actually our slope value. So what we're going to do on the next few slides is we're actually going to look at equations. We're going to use the equation to help us find our y-intercept and our slope, and then we're going to utilize the y-intercept and slope to actually create an accurate graph of that linear equation. So this form that we saw in the previous slide is more formally known as slope-intercept form. And slope-intercept form occurs when we have y alone. So this is called function form. And then once it's written in function form, our slope is the number in front of x, so that's the coefficient of x. And our y-intercept here is our constant value without the x. So this is commonly known as slope-intercept form. You'll also hear it as y=mx plus b. So what we're going to do in these examples down below is we're going to identify the slope and the y-intercept in each equation. So if I look at this first example here, I'm going to find my slope and my y-intercept. My slope, I know, is the coefficient of x. So here, if I look for the coefficient of x, I notice that the number in front of x is 3. So here my slope has a value of 3. And if you like to write it as a fraction, you can write it as 3/1. Either is fine. Then my y-intercept point is my constant. Now I'm going to use keep, change here so that I can make sure I see that my y-intercept point is this constant value of -6. So my y-intercept is occurring at x is 0, y is -6. Now if I move on and I'm going to go down below, I'm going to kind of go counterclockwise here. So I'm going to start down here. I'm going to look for slope and y-intercept again. So my slope, remember, is the coefficient of x. So here I can see, I'm going to use keep, change. My coefficient of x is the number in front of the x. So my slope is actually a -3/4. So it's not always first. Your slope is the coefficient of x. Your y-intercept is then the constant value, which here I can see is -2. So my y-intercept occurs when x is 0 and y is -2. Then if I look at the next example, here I can see that I have a situation where I can utilize keep, change. And then I need to identify my slope and my y-intercept. So my slope is the coefficient of x, which is the number in front of x, which here is -2. If you want to write that as a fraction, you can write it as -2/1. And then my y-intercept point is my constant value here, so this 4. So my y-intercept is occurring when x is 0 and y is 4. Finally, this last example here, this one's a little bit tricky because of the way that it's written. Remember that if there's not a number in front of the x, that they're implying that there is a -1 value there. So what this is really saying is you have -1x, and then we can find our slope by looking at the coefficient of x, which we can see here is -1. And if you want to write that as a fraction, it's just -1/1. Now, our y-intercept point is also a little bit tricky in this particular example. So the y-intercept point here is not none. Just because you don't see a plus something doesn't mean that there isn't a y-intercept. So here what we need to think about is what number could possibly be there as the y-intercept. And what I think about is the only number that I could add in there and not change the value of the equation is 0. If I do a +0, I don't really change the value of anything. I'm just writing in a +0. And what that's telling me is if there isn't a number there for the y-intercept, my y-intercept is really the point 0, 0. So that last one is a little bit tricky, but for the rest of them, your slope, you're looking at the coefficient of x, and then your constant is your y-intercept value. So what we're going to do at this point is we're actually going to start graphing by utilizing slope-intercept form. So our first step when we utilize slope-intercept form is we need to remember that slope-intercept form is y equals mx plus b. So what we need to always do first is we always need to rewrite our equation so that the y value is alone and that it's actually in slope-intercept form. So here in this example, we have 2x plus 3y is equal to 12. And we want to rewrite this equation so that y is by itself. So the first thing that we need to do is we need to subtract 2x from each side. And in doing so, this is going to become 0. And then on the left-hand side, we're left with 3y is equal to, we're just going to write 12 plus a negative 2x because those are not alike terms. Then from here, I need to divide each side by 3. So I end up with y is equal to 12 divided by 3 is 4 plus a negative 2 over 3 times x. So now that I have it written in slope-intercept form, I can identify the slope and the y-intercept point. So my slope, remember, is my coefficient of x. So here I can see that my coefficient of x, the number in front of x here, is a negative 2 over 3. Then from here, my y-intercept value is this constant value over here, the constant by itself. So my y-intercept value is x is 0, y is 4. I'm crossing the y-intercept at the y value of 4. So now that I have this key information, I can go to my graph and I can actually start plotting. So the first thing I'm going to do is I'm going to plot my y-intercept point because I know that that is a specific point on my line. So here I'm going to go to x is 0, y is 1, 2, 3, 4. So we have x is 0, y is 4. Then from here, I can use my slope to help me plot additional points. So remember that our slope is really the equivalent of our change in y, which is our rise, and our change in x, which is our run. So we're talking about our vertical change over our horizontal change. So right here, this negative 2 represents our vertical change. And this is saying that we're moving vertically in the negative direction 2. The negative vertical direction is down. So this is telling me that I need to go down 2 points. And then this 3, because it doesn't have a sign next to it, is actually plus. So then we're going to move in the positive horizontal direction, which is to the right, 3 points. So to find an additional point, we're going to go to this 0, 4, and then we're going to follow this pattern. We're going to go down 1, 2, and then to the right 1, 2, 3, and plot our point. So a second point on our line by utilizing our slope is x is 3, y is 2. And then I can take that same pattern and go down 1, 2, to the right 1, 2, 3. So I have another point at x is 6, y is 0. Now once I see this pattern, I can also apply it backwards by going up 1, 2, and then backwards 1, 2, 3. To find that I have a point at x is negative 3, y is 6. So I can use that slope pattern to help me actually plot additional points to go on my graph. Now from here, all I need to do is connect my points, and I can draw an accurate line. I'm going to connect them all, put an arrow on the end, go all the way through the coordinate plane. So now I have a nice accurate representation of my line. All of those points on that line are what make this equation true. Now the final thing I need to do is I need to actually determine my domain and my range. Because my graph is going forever to the right and forever to the left, my domain is all real numbers, and my range is going forever up and forever down, so my range is also all real numbers. So next example here, I notice that this one is already written in slope-intercept form. So I actually don't have to rewrite it. So it's already been written correctly. We already have y by itself. So what we can start off doing right off the bat, because it's in y equals mx plus b form, is we can actually start by identifying our slope and our y-intercept. So remember, our slope is the coefficient of x, which in this case I can see is 1 over 2. And then my y-intercept point, I'm going to use keep, change here, is my constant value, so -5. So my y-intercept is occurring when x is 0 and my y value is -5. So in order to graph this on my coordinate plane, I'm going to start by going to my y-intercept value. So I know that I'm crossing the y-intercept when y is -5, so I can go plot 0, -1, 2, 3, 4, 5. So I can plot that point. X is 0, y is -5. Then from here, I need to plot additional points utilizing my slope. And remember, slope is my rise over run. So since these don't have symbols, that's implying that both of these are positive values. So what this is saying is we're going to move 1 in the vertical direction, and we're going to move 1 in the positive vertical direction, which means we're going to go up 1. And then we're going to move 2 in the positive horizontal direction, so we're going to go to the right 2. So that pattern of up 1, right 2, up 1, right 2 is going to help us find additional points. So we're going to go up 1, right 1, 2, and plot. So we're at x is 2, y is -4. Then we go up 1, right 1, 2. So we have another point. X is 4, y is -3. And we go up 1, right 2. So we have an additional point. And then that point is x is 6, y is -2. We can also apply that pattern backwards. We'd go down 1 and to the left 2. So that would be the point x is -2, y is -6. But already here you can start to see a really nice representation of our graph. So then we connect all the points, putting arrows at the end as we extend through the entire coordinate plane. And then finally, we need to determine our domain and our range. Since it's going forever left and right, our domain is all real numbers. And our range, because we're going forever up and forever down, is also all real numbers. So third example here, we're going to start by getting this into slope-intercept form. So remember, we need y alone, so y equals mx plus b. So we need to get this y value completely by itself. To start, I'm going to utilize keep, change to prevent any errors. And then I'm going to start rewriting this equation for y by itself. So I start by adding the 6x to each side so that those cancel out there. And we're left with -2y is equal to -12 plus 6x. And since they aren't like terms, I do not combine them together. Then I'm going to divide both sides by a -2. So I have y is equal to -12 over -2 is 6 plus, here we have 6 divided by -2, which is a -3x. So we now have this rewritten for y by itself. Now our next job is to determine our slope and y-intercept of this line. My slope, I know, is the coefficient of x, so I'm looking for the number in front of x. And here I notice that my slope is -3. And I know that I'm going to be plotting my slope later. So remember, we can turn any integer into a fraction. So we can turn it into rise over run by simply putting it over 1. Then from here, my y-intercept is the constant term by itself, so that's simply 6. And we're going to have our y-intercept point be at x is 0, y is 6. So I'm going to go over to my graph and plot my y-intercept, which is occurring at x is 0, y is 1, 2, 3, 4, 5, 6. So x is 0, y is 6. Then I go over to my slope, and I notice that it's -3 over 1. So I know my rise, I'm moving down in the vertical direction 3. And then my run, I'm moving to the right in the positive direction 1. So to find additional points, I go down 1, 2, 3, right 1 to the point x is 1, y is -3. Down 1, 2, 3, right 1 to the point x is 2, y is 0. Down 1, 2, 3 to the right 1, so we have x is 3, y is 3. And then we could continue that pattern, but here I can see I have a pretty good shape of what my line looks like. So I'm going to connect the dots, extend it fully through my coordinate plane, and add arrows onto the end. Then to end, I need to determine my domain. Because it's going forever left and right, my domain is all real numbers. And because it's going forever up and down, my range is also all real numbers. And last example like this. So again, I notice that this isn't written in slope-intercept form. So I know I need to rewrite the equation so that the y value is by itself. So I start by adding 4x to each side. So those will cancel out. So I'm left with 3y is equal to -9 plus 4x. Then I'm going to divide both sides by 3. So I end up with y is equal to -3 plus, this is just a fraction of 4/3 x. Then from here, I need to identify my slope and my y-intercept. My slope is the coefficient of x, so that's 4/3. And then my y-intercept is the constant value. So I know my y-intercept is that x is 0, y is -3. So then from here, I go over to my graph and I plot my y-intercept at x is 0, y is -3. And then from here, I'm going to apply my slope. So here I have my rise as a +4, so I'm going to go up 4. And then my run is a +3, so I'm going to go in the positive direction, which is to the right, 3. So my pattern is I'm going to go up 1, 2, 3, 4, to the right 1, 2, 3. So here I'm at x is 3, y is 1. Up 1, 2, 3, 4, to the right 1, 2, 3. So I'm at x is 6, y is 5. Then I can also apply that pattern backwards by going down 1, 2, 3, 4, and to the left 1, 2, 3. So here I'd be at x is -3, y is -7. So then I can take those points and connect them, extending them through the coordinate plane with arrows on the end. And then I can find my domain and range. Because I'm going forever to the left and right, domain is all real numbers. Because I'm going forever up and down, my range is also all real numbers. And lastly, we're going to look at a word problem here. So here it says your family spends $60 on tickets to a hockey game and $4 per hour for parking. The total cost, C, in dollars, is given by C equals 60 plus 4 times T, where T is the time in hours your family's car is parked. So the first question says, what is the slope? So if we go over to our equation, what we realize is we need to determine our slope. Our slope is the coefficient of the variable t. So our slope is simply 4 or 4/1. Our y-intercept value is the constant value. So that's this 60 piece here. So our y-intercept value is x is 0, y is 60. So the first part of that is just being able to look at the equation and still identify key information. Then from here, we're actually going to determine what these mean in the context of the problem. So this says, what does the y-intercept represent in the context of the problem? So let's break this down a little bit. So that 0 represents the value of t. So what this y-intercept actually represents is the cost before we park. So essentially this is our constant cost. We're going to have to pay $60 for the tickets. So at time 0, before we've actually started paying for parking, we're actually going to pay $60 up front just to go to the hockey game. So that's what that y-intercept represents. Now our slope, if we look at what that represents, our slope is the 4/1. So let's take a moment and try and remember, what does the y unit represent and what does the x unit represent, or what does t represent? So our y is over here on the side. So this 20, 40, 60, you should be remembering is in dollars. So that's actually $4. And our t value, which is along our x-axis, is time, which is in hours. So this slope represents a rate of change, and it's saying that the cost will increase $4 per hour